Okay, here's another interesting question. We have this block of mass, a system of masses, two of them connected together by means of a string that is made to pass over this smooth pulley. The tension in the string is the same as this that is opposing this, and the one that pulls this, let's call this block M1 along this direction. Okay, you can see the analysis. I think I'm able to show the forces acting on these masses. Okay, the weight of M2, that's 15, that is mg. The mass is 15. This g is mass acceleration to gravity, and maybe that will be taken as 10 meters per second squared. That's mass acceleration to gravity. All right, so the mass of M1 is 10 kg, and the weight acts vertically downwards. I call that M1g. M1g is going to be 10 times 10, that is 100 Newton, because the mass is given as 10 kg. Now we can also draw the normal force acting from the or at right angles to this inclined surface. And if I resolve my mg, they already shown this in my previous videos how to resolve the weight line. That is this mg has two perpendicular components. One of them is mg cos theta, which is balanced by the normal force, and the other is mg sin theta, which acts down the plane. So we are going to resolve for the forces acting along the direction of motion only. Now M1 moves along or in this direction, while M2 moves vertically downwards. So my coordinate system implies that I'm going to take any force acting to the direction of positive x-axis as positive, and any force acting this way negative. My downward force is taken as positive because that's the same direction of motion, and the upward force here will be taken as negative. So the question says the surface upon which M1 lies is smooth. We have to calculate the acceleration of the system. The acceleration of the system, okay? Let's resolve for the forces acting along the plane. Okay, I'll say here resolving along the plane, along the inclined plane. I have t minus mg sin theta, which is equal to ma. Let's call that m1a. Okay, this is t by m1 because that's form as m1. I call this equation 1. For the second equation, I have m2g, that's for this, minus t is equal to m2a. Okay, call that equation 2. Now I'm going to add these two equations, okay, so that t cancels t. So I have m2g minus m1g sin theta is equal to a. That is, I'm adding this together, m1 plus m2. Okay, I have to do this first in symbols, and then I'll make my substitution. My m2 is 15, so 15 times 10, okay, minus my m1 is 10 times 10. My theta is 30 degrees, that's the angle of inclination. That gives me my a into 10 plus 15, okay. Now this gives me 150 minus 100 times sin 30, that is 100 times sin 30 0.5 is equal to, this is 25a. Alright, so that gives me 150 minus 50 equals 25 times a. Alright, so we can evaluate this. That gives me 100 equals 25a. So their common acceleration is 4 meters per second squared, okay. So if other questions are asked, probably if a block M2 starts falling from rest, now they may ask you to calculate the speed of the block if the distance from this point to the surface or the ground is given as let's say 3 meters. What will be the speed before it hits the ground? Then you can now equate that to, you invoke this equation of motion. So since it starts falling from rest, u is 0 plus this acceleration, that is 4 times t, that is if it falls for some time t. Okay, since time t is not given, I can go back and use the equation of motion, that is the third equation, v squared equals u squared plus 2as, okay. Now we are looking for the speed, u is 0 because start from rest, plus 2 times 4 times 3, if the distance falling is 3 meters. So that gives me v squared is equal to what? This is 2 times 4, 8. 8 times 3, 24. So v equals the square root of 24. So you can decide to quickly look for the square root of 24 on your calculator. That gives you 4.9 meters per second approximately. Now, how about in the case where there's frictional force that acts between the surface of the inclined plane and M1? Suppose you are told that the coefficient of kinetic frictional force mu k is 0.3. How do we calculate their common acceleration? In that case, for this block, let me just draw the free body diagram of block M1 when frictional force acts. So the forces acting in this direction will be the coefficient of that is kinetic frictional force and the mg sine theta. Okay, these two forces act opposite motion and against the tension in the string T. So that's the free body diagram of block M1. Okay, so here the tension T will be equal to, or will be this as a resultant force on mass M1 will be equal to T, which is positive, minus Fk negative, minus mg sine theta. Okay, that equals mass times acceleration M1. Okay, this is also M1. Okay, so that is that for equation 1. All right, so I have, this is what we are looking for. We are given the coefficient of static friction, and my Fk is mu k times normal reaction. The normal force is equal to mg m1g cos theta. That is a component. The normal force is a component of this m1g that acts at right angles to the plane. So maybe I can evaluate my Fk first of all. That gives me mu k m1g cos theta. My mu is 0.3 times m1 is 10 times 10 cos 30 degrees. So that gives me, this is 30 cos 30. Okay, so 30 cos 30, that gives me 25.9. 25.9 Newton. Okay, that is my static, that's my kinetic frictional force. Alright, I come back to this equation now. I have T minus 25.9. Let's just simplify things. Round it off to 26. Minus 26 minus my mg sine theta. I got that as what, 50 is equal to ma. That is 10 times a. So I have T minus 76 is equal to 10a. Let me call this my proper equation 1. Then I'm going to resolve vertically. For the forces acting, I have m2g and the tension in the string T. Okay, so that gives me m2g minus T equals to m2a, equation 2. Okay, my m is 15 again, times 10 minus T is equal to 15a, equation 2. So I'm going to add these two equations. These two equations are added. So that T minus T is gone. I have 150 minus 76 is equal to this plus this 25a. So 150 minus 76 gives me 74 equals 25a. So my acceleration now common is 74 over 25. I guess I'm not mistaken there. So go through for me. In case I make any mistakes, you know that I'm trying to run with time. Alright, so that's this is a case where you can see the difference now. Because of frictional force, that has affected the acceleration. When we solve for the acceleration with the smooth inclined plane, the acceleration was 4.0 and all that. But with the presence of frictional force, the acceleration has reduced from 4.0 to 2.96 meters per second squared. Alright, so let's look at other calculations in next video. Now, next videos I'm going to look at one or two problems on the motion of a lift.